Hello everyone, welcome back to my YouTube channel. In this week video, I'm going to explain to you how you should answer quiz 6 question. Altogether, we have 5 different questions and let's start with the first one. Question number 1. A gas temperature of T1 is kept in a closed container. If the average kinetic energy of the gas increases to 3 times its initial average kinetic energy, determine the final temperature of this gas in terms of T1. Alright, so since we are going to calculate the average kinetic energy, so we are going to use the formula 3 over 2 times RT1 is equivalent to 3 over 2 RT1 because they want it to be in terms of T1. But then in the question states that it increases to 3 times its initial average kinetic energy. So this one we need to times 3. So in other words, so R we can slash out because it's the same for both. So 3 over 2 T1 is actually equivalent to 9 over 2 T1, right? So same goes as 3 T1 is equivalent to 9 T1. So T1 is equivalent to 9 over 3 T1 equivalent to 3 T1. So this is the final answer for the first question. Moving on to question number 2. Determine the root mean square velocity of a molecule in a sample of nitrogen gas at 0 degrees Celsius, given that the atomic mass of nitrogen is 14.0097 gram per mole. Right, so the question asks you to calculate the root mean square velocity. So the velocity of root mean square is equivalent to square root of 3RT divided by the molecular mass. So the molecular mass for nitrogen is equivalent to, because you were given the atomic mass, right? So 14.0067 times 2, because this is a nitrogen gas, and 2. So you will get 28.0134 gram per mole. Right, so you need to make sure that you need to convert this instead of in gram, convert this into kilogram. So you need to divide by 1000. So when you divide this by 1000, you will get 0.02801 kilogram per mole. Alright, so let's calculate this root mean square velocity by plugging in the value. So VRMS is equivalent to the square root of 3RT over molar mass, but in kilogram. So it's over 0.02801 kilogram per mole. Right. So I'm just going to copy this again. So 3. So what is the gas constant? 8.3145 joule per Kelvin per mole. And your T is at 0 degrees Celsius, but you need to convert that into Kelvin. So 273 Kelvin divided by 0.02801 kilogram per mole. So this one is Kelvin and then Kelvin. So this one mole. This one is mole. So leaving you with joule per kilogram, right? So remember that joule itself is actually equivalent to kilogram meter square per second, right? So means that you need to convert this again into this unit, right? So just to make it clearer for you to see, I'm going to write this again. So we need to calculate this, and you will get 6,809.5755. It should be in joule, but then we are going to convert into here. It's going to be kilogram meter square per second divided by 0.02801 kilogram. Right. So again, we are going to slash out any other things. So you will end up having the square root of 243112.2992 meters square per second. Right, because this is square root, right? So you should get your final answer will be 493.0642, and look at the unit should be meter per second because you already do the square root. So this is the final answer for the second question. Let's move on to question number 3. By implementing the Boltzmann constant, determine the average translational kinetic energy, RMS, of 6 mole of gas molecule at 32 degrees Celsius. Right, the first thing that we need to look at is how many moles of gas we are talking about. So 6 mole of gas molecule. So given to you is 6 mole of gas molecule. So 1 mole of gas molecule is equivalent to the Avogadro number of molecules. Right? So 1 mole is the Avogadro number. Therefore, we have 6 mole. So 6 times Avogadro number, which is 6 times 6.0221 times 10 to the power of 23. Therefore, it is equivalent to 3.6133 times 10 to the power of 24 molecules. Alright, so from here, then only you can use the Boltzmann constant to find the average translational kinetic energy. So the formula is kinetic energy, RMS, is equivalent to 3 over 2 N, and then constant Boltzmann times T. Right. So what is N? N is the number of molecules, which is the one that we have just calculated. And then we have to plug in the Boltzmann constant. And then the temperature should always be in Kelvin. So given to you is in degrees Celsius. So 273 plus 32. So you will get 305 Kelvin. Have to do is just plug in all the values that we have. So 3 over 2 times your N, you have calculated just now, 3.6133 times 10 to the power of 24. And then the Boltzmann constant, 1.3807 times 10 to the power of negative 23. So this one is in molecules. So the unit will be joule per Kelvin per molecules. and then your T will be 305 Kelvin. Right. So from here, you can slash out all the unit that you don't want. So this one is per Kelvin. So this one is Kelvin. This one per molecules. This is molecules. So you will end up with joule. Alright, so next up, you just have to plug in the value. So again, 3/2 times 1.5216 times 10 to the power of 4. Hence, you will get your final answer will be 2.2824 times 10 to the power of 4 joule. So this is the final answer for the third question. Moving on to question number 4. Refer to the chemical reaction below. If the rate of formation of ammonia is 0.345 molar per second, what is the rate of disappearance of hydrogen? From the equation, you should be able to write the rate expression. So rate expression is equivalent to rate equivalent to negative delta concentration of N2 over delta T equivalent to 1/3 delta concentration of H2 over delta T equivalent to positive 1/2 delta concentration of NH3 over delta T. Given to you in the question, the rate of formation of ammonia is 0.345 molar per second. Means that over here is equivalent to 0.345. So you were asked to calculate what is the rate of disappearance of hydrogen. In saying that, you can write 1/3 delta H2 over delta T is equivalent to positive 1/2 delta concentration on NH3 over delta T, whereby your NH3 is equivalent to 0.345. Right, so we can say that 1/3 concentration of delta H2 over delta T is equivalent to 1/2 concentration of NH3, so 0.345. Hence, you will get 0.1725. But you only need delta concentration of H2 over delta T. So this value 0.1725, you need to times 3. Hence, you will get your final answer is equivalent to 0.5175 molar per second. Alright, but then we need to see that your H2 is actually at the reactant. So since it is at reactant, so you need to have minus over that. So this is the final answer for your fourth question. Right, so let's move on to question number 5, the last question for this week video. The rate constant for the first order reaction for the reaction below at 600 Kelvin is 2.2 times 10 to the power of -5 per second. Determine the percentage of SO2Cl2 decomposed upon heating at a stated temperature for 90 minutes. Alright, so this is a very simple question. You need to know that this is a first order reaction. So since that this is a first order reaction, so the formula that you can use is ln AT is equivalent to negative KT plus ln A naught. Alright, so what else is given to you in the question? It states here that the rate constant, which is the K, is equivalent to 2.2 times 10 to the power of -5. And then determine the percentage of this upon heating for 90 minutes. So given to you is the T 90 minutes. So this 90 minutes you need to convert into seconds. So 90 times 60 because 1 minute is 60 seconds. So you need to convert this first and then plug in into here. So you can write ln 80 is equivalent to negative k, which is 2.2 times 10 to the power of negative 5. And your t is 90 times 60 plus the concentration of ln A naught. Alright, so from here you will get negative 1.1880 times 10 to the power of negative 1 plus ln A naught. Okay, so basically what we are going to do is we are going to assume that your A naught is equivalent to 1 because at first it will be 100%. So we are going to substitute the A naught here with 1. Therefore, since ln 1 is equivalent to 0, you will end up with ln 80 is equivalent to negative 1.1880 times 10 to the power of negative 1. So it's easier for you to find what is 80. Negative 1.1880 times 10 to the power of negative 1. So you will get 0.8888. Alright, but this is not the end because you were asked to determine the percentage, right? So we need to calculate the percentage instead of just knowing what is the concentration. Alright, so what we can do now is, because we assume that your A naught is actually equivalent to 1, which is 100%, and your AT is 0.8888, just like the calculation that we do just now. Hence, what we are going to do now is just minus the initial, which is 1, minus with the final 0.8888, and then this value we are going to times 100 because we want it to be in percentage. Therefore, you will get your final answer will be 11.12%. So this is the final answer for the final question. Alright, so we have come to the end of this week's video. I would like to thank all of you for watching this video from the beginning till the end. So I hope that this video will help you to understand more on how to answer quiz 6 question. So I'll see you again next week. Take care and be good. Goodbye.